All right. Well, I think 10:03, the beeps have slowed way down from people joining. So we'll get going. Just gonna a little bit of introduction about myself, about the whole thing, about the workshop, what we'll be doing and won't be doing. Um, so we're scheduled to run from 10 a.m. to 11 a.m. So 1 hour. Normally it goes for almost a full hour. So hopefully we'll be finished at about 2 minutes to 11. So I'm Justin. I work at Bond University on the Gold Coast at the Institute for Evidence-Based Healthcare. We do a lot of systematic reviews here, and many years ago, we started to develop automation tools to help do systematic reviews faster. We put a lot of these up online and made them available to people, and their popularity grew. So we decided to kind of expand the program and develop a new platform. So we have, sorry, it's my phone. Um, so we've now developed a new platform called the Evidence Review Accelerator, which over time will replace the Systematic Review Accelerator. So today's workshop is all about the new platform, all of the tools. If you have no idea what a Systematic Review Accelerator is and have never heard or seen of it, it's fine. It doesn't matter. I'm going to cover every single tool, assuming no one has used automation tools before. So I run the automation program here. So I've basically helped build every tool that we'll talk about today. Before we get going, in regards to questions, oh, Gabriel's already asked a question. Um, when will the recording be available? We're not sure. Probably normally takes about a week. So Melanie is on the call, who does a fabulous job of just editing it and making sure any F-bombs I drop get edited out. So yeah, normally a week after we run the workshop, it gets made available to everyone. So questions. So it's a very tight session. There's a lot to get through. So if you have a question, please put your question into the chat box as you think of it. Because if you're anything like me, I always forget my questions halfway through thinking about it, and then I start looking at something else and I forget it. So please, if you have a question, put it in the chat box as you think about it. I'm not going to answer questions like through the session, so from 10 to 11 or whenever we finish. I don't really pause and stop and answer questions, but at the end of the workshop, after everything's been demoed, I then go back, have a look at any questions that are there and answer any of the questions that were asked throughout the workshop. So if you want to, hear answers to questions, hang around afterwards. I always hang around until there's no more questions. It's also, if you have more complicated or longer questions that, you don't want to type into the text box, hang around and you can ask your questions just in person as well. So I always hang around till, normally 15, 20 minutes after the actual workshop finishes, just to answer any questions or go over things again if people are interested. That's about it. So I do start off with a very short little bit of a PowerPoint intro to some stuff. It's very short. Most of the session is just me demoing how the tools work. So that's about it. So we'll get started. So today's session is all about using automation tools to help do systematic reviews faster. Yeah, I'm Justin, although I'm not a senior research information specialist anymore, but that's all right. Before I get going, I always like to just show these four fantastic people. So these are the four computer scientists who work with me on the automation tools: Matt, Connor, Tian, and Irene. They do a lot of the coding, most of the coding around the tools. So we work together to make all the tools available. I always like to make sure they get some credit because they're very shy, retiring people and don't tend to get out in front of an audience very much. Evidence synthesis tasks or systematic review tasks. There's 6 basic things you need to do to go from not having a systematic review to having a finished systematic review. First thing is writing the protocol. So this will help you structure and write your protocol, basically, which is your formula for doing your review. It's the first point. First thing you do, you kind of design your review. It doesn't have to be completely final, but the idea is to kind of have something structured in place that you then follow to do your review. Second thing to do is to find some studies. So to find some studies, you do a search, normally over some bibliographic databases, so PubMed or Cochrane. Select some studies. You do that generally by doing it manually, by going through and looking at each study that the search finds in parallel with a partner and deciding if it's includable or excludable based upon the criteria in your protocol. Then you extract and assess the study data. So when you get down to a group of, say, 10 studies that are going to be in your review, you pull the data out and you then assess the studies for quality, doing risk of bias or some other way of assessing quality. You synthesize the study data, so therefore you put it all together, either in a meta-analysis or you can describe it narratively, and then you write the review. So we have tools to help with all of 6 of these things. None of the tools do it all for you at all, but we do have stuff to help make it a bit quicker. So they're all of the, oh, sorry, I shouldn't go too fast. These are half of the things you need to do a review. I won't go through it all because we do have this written out in the TERA platform. It's a bunch of stuff here and a bunch more stuff. So these are all the steps you need to go through in fine-grained detail to do a review. This is not the Systematic Review Accelerator. This is the Evidence Review Accelerator. That's the website there, tera-tools.com. All of the tools are on the left. I'm going to be showing it all live very shortly. But this is always the most important take-home message or important note about the workshop, about all of these tools. These tools do not replace the need to know what you're doing, or at least to have some people on your review who know what they're doing. These tools have been designed to enable people with skills to use their skills more efficiently. Also, people, maybe novices, of course, you can have novices on your review who may not have that many skills in doing reviews. They can also use the tools and it will help them. But these are not magic tools. I mean, they're pretty magic, but they're not real magic. You can't just look at the tool, press a button, and have your review done for you. There's still hard work, a lot of thinking, a lot of processing of stuff. So you can't just expect this to magically make a review materialize with the press of a couple of buttons. And I think that's it. For slides, there's a bunch more, but they're not as exciting as looking at the real tool. So this is the Evidence Review Accelerator, or TERA, as I'll probably be referring to it. This is the front page. I guess there's some webinars there. If you're new to TERA and new to reviews particularly, I highly recommend starting to watch these videos. So these are, well, the TERA overview video is just a webinar I did similar to this one a few weeks ago. But the workshops are all in-depth, focused workshops on different phases of the review, done by 5 different experts in each of these different things. They go for just over an hour each, I think. All of them will really help. So when you're designing your review, I highly recommend going and watching the workshop 1, designing the review. Getting started with TERA. I'll go into my projects. So I have a lot of projects. TERA is a freemium platform, which means there's a free version and a subscription version. The free version allows you to create and run one project at a time and allows you to screen 1,000 articles in our Mecha Screener tool, so our automatic generative AI screening platform. So one project, 1,000 records screened using the free platform. That's the only difference. Everything else is available to use without, needing to pay. I know there's a few Bond people on. If you're a Bond person, so if you're a staff or student at Bond University, you don't have to pay. Please get in touch with myself or Melanie, and we will provide you with the Bond free access accounts. Whether you've got a free version or whether you've subscribed, you can join as many projects as you want. So there's no limit on the number of projects you can join. So if someone else has created a bunch of projects, if you're working on 5 different reviews with people and they created all of them, you can join 5 reviews with the free, using the free version. So that's the only difference. Create multiple projects, screen a lot more studies in Mecha Screener. To get started, to do anything at all, you need a project to get going. To get a project going, you have to hit the Create New Project button. If you're using the free version, once you've got one project running, this button disappears. If you're subscribed, this button stays there no matter how many projects you create. So hit Create, then give your project a name. I end up with a lot of these, so I need to make it very clear which ones are safe to delete. So give your project a name, then you can select your project type. We support quite a few different things now, some better support than others, but we support 3 different types of studies now. So we support what's called clinical audit studies. This is still quite new, but I'll just get one of these started. So click clinical audit study, create project, we'll get you going. In theory. The internet here today at Bond is creaking a bit for some reason. Or creaking a lot. Oh, sorry, that was working last week. And I'll try Microsoft Edge instead. Uh, in theory, oh no, it did create it. Uh, so the internet here is pretty creaky. All right, so this is a clinical audit project. So what it will do is it will just load in the tools available for that type of study. So at the moment, we've only got a protocol writer. So this will help you write a protocol for your clinical audit study. You can change your study type. If I change to randomized trial, what it will do is it will then load in the tools we've got to help do a randomized trial. These are another trials wizard, which would help you write your protocol for a randomized trial or a clinical trial, and a couple of stats and reporting tools. So not a lot, but we do have a couple. I'm not going to go into the protocol writing tool for it because I've spent a bit of time on the protocol writing tool for systematic reviews. So I'll switch this. We have scoping review support as well, but I'll just stick to systematic reviews. So once you've done, you can see we have a lot more tools to help do systematic reviews than we do the other ones. To invite someone into your project, so everyone can work on it together, you hit invite people via email button. This sends them an email, and if they have an account already in TERA, they just click a link and they will join. If they don't have an account, they can prompt them to make an account and then join. So I'm going to invite Matt. So you just type in their email and you send an invite. This will then send Matt an invite. Currently he's invited. When he accepts the invite, that will change to member of the project. As you invite people and work with people on your projects, a list of people shows up from your other projects. So to invite one of those, you can just click a button and hit send invite, and it'll just make it a bit quicker. So if you work with people quite a bit, just makes it a bit easier to invite them to projects. A short project name, this can be helpful, and then a description as well. I'm not going to write one in since I'm going to delete this later. So that's kind of getting started, creating projects, inviting people, switching between different project types. To do anything really, to use most of the tools, you'll need a file in here, generally a file of references. This is the project files area. So to get some files in, hit upload files, and I'll upload these files here. So these are 10 references that I've exported from EndNote in an XML format. So it will upload them, it will process them, and it will show you that there's 10 references in there. You can have a look at them by clicking on it, and you can even go in and add some data and edit them as well. You can upload anything. You can upload Excel spreadsheets if you want, or PDFs, or other things as well. To delete them, there's quite a few ways to delete them. Delete buttons and other things. Working with files it's pretty standard, so I won't go through it too much. So that's how you get files in to TERA. And there's generally one thing I always forget when I do this, but I think that's probably it. You can download it, upload more files, refresh files list. There's a button that says show hidden files. We recommend you don't click that. I don't have any at the moment, but that's all kind of the hidden inner workings of all of the tools. And then there's a bunch of JSON files, they're called. So generally I suggest not clicking that button. So that's kind of all of the project management stuff, getting files, inviting people, working with things. We have a project history as well. If you really get really excited, you can see exactly everything that's been done. So I'm going to move on and I'll start working through the review wizard next. So this is the review wizard. So this is a protocol writer to help write the protocol for your systematic review. All of the different wizards for the different study types are very similar. They have a title page. It will give it the same title as your project, but you can override it. I use blue light a lot. Done, then I'll move down to people. So to have people do stuff and get named as authors, you need to put them in here. You can add as many as you like. I'll just add some of my usual suspects in. You can also do some acknowledgements as well. So Mark is quite often helps us out with some stats. So you just add people in, and as I go through the review wizard, you can assign jobs to them or say who's doing what. We have a very neat review plan, so I highly recommend having a look at this when you start a review. So the review plan is quite extensive, and it's basically every single step you need to go through from start to finish your review. As people get assigned to different tasks, their names will go in there. You can also make notes as well. So these notes are good things to kind of, I don't know, keep notes on where you're at and what's going on. And then as you complete a task, you can hit completed. And you can also download the whole thing as an Excel spreadsheet if you prefer Excel spreadsheets to working online. So that's the review plan. So then the introduction. So introduction, we don't help you. Oh, so that's the whole review plan there downloaded. So we don't help you write your introduction. Well, we kind of do, but all we do is we give you a couple of pointers on how to write it. And then we give you an example from our blue light therapy. So we did do a blue light therapy for acne review, which is published a long time ago now. So we've just provided the intro there for that review, just to give you a bit of a feel and understand how an introduction should be structured. So it's just guidance. You need to write this. You can type it straight in, or you can write it into a Word document and copy and paste the introduction in. There's no magic to help you write an introduction. Where the magic starts to happen is here on the methods downwards. So this is the part of the review wizard where you start to answer some of the questions that we've asked or that you need to answer in order to do a review. So for instance, here population, people with acne is your population. You might add an exclusion criteria of children, for instance, because you don't want children with acne in your review. Intervention, you can add examples as well. Now, I don't know if that's right, by the way, but if you put in the examples, they'll also get used a bit later. Comparator, very similar. Add it in, usual care, outcomes, setting, you might and again, you might add an exclusion of anyone in hospital you don't want as part of your trial. And then the types of studies you're looking for as well. So types of studies here, but there's always an other button. So every single option that you might be asked to fill in, there's an other button. So you can always just add in whatever you would like. So you might want to add in non-randomized study. You can add that value, and then that will just add it in for you. And that other button is available on every single option. Search strategy, same thing. So here is where the author list starts to pop up, and you can now say, well, I'll do the searching. I'm going to be using some of this stuff to do my search. Any tools you might use, whether it was peer-reviewed, restrictions, who's doing supplementary searches. So maybe you'll do some of that, backwards, forwards, citation searching, and the tool you might use. Search strings, which databases you'll search. When you ran your search, you can put your search strings in there. Study screening, who's going to screen. So maybe Matt and Sharon will screen. That will start to tell you how many people. So as you pick someone, the number of authors who independently do it is automatically filled out for you. Same with citation searching, and then any tools as well that you might have used. And then whether or not you follow reporting via Prisma, which you should always do, by the way. So I'm not going to go on too much more, but data extraction is just one thing it's well worth spending a little bit of time on. So you might pilot the study normally on 3. I guess me and Matt can do that. We highly recommend filling this out early and starting to think about it for many reasons. So what we've done is we've gone through and we've pre-identified a lot of the various bits of data that you extract when you do a systematic review. For instance, you almost always extract study authors and year, study design, duration of follow-up. Number of participants, very common, age, the type of intervention, but maybe there's something we're missing here. So maybe the wavelength of the intervention is something you might want to extract. So you can add that in and I'll pop it in, usual care, acne reduction. So this will all get pulled over from the PICO section. So this section, this will all automatically fill out. So the good thing about doing this is it kind of gets you thinking about what data you're going to extract first, but also if I go down to the extraction forms, it will start to create data extraction forms for you in TERA. So every single option you've put in gets added here. You can actually use this to enter your data, or you can just download it, and this actually will then give you eventually. So it just creates the data extraction form for you based on what you selected. Now you may not use them all in the end, but it's just much easier to kind of have something ready and have something extracted and everything pre-identified, ready for you, rather than having to create one that's just completely from a blank Excel spreadsheet. The same thing with study outcomes as well. We'll start to put in the study outcomes. So that's it for data extraction, assessment of risk of bias. Same thing, we got most of the tools, measurement of effect, which software you're going to use, unit of analysis, normally individual, any missing data strategy, heterogeneity, publication bias, any subgroup analysis, where you registered it, and then contributions is quite handy, as I always hate filling this bit out because I always do it right at the end and I'm a bit over it by then. So we use the credit system, which seems to be the popular one that everyone uses. So for instance, I might have done some of that. Matt might have done some of that, and then Sharon might have done some of that. This then gets you a nice output for your output, and it kind of outlines what everyone did for the study contributions when you go to publish. Similarly for acknowledgements, Mark might have done some stats and read an early draft as well. So the whole point of it though is if I go to, this is what I've done previously. Hopefully it will load a bit quicker. Well, it will load eventually. I might have to come back to it a bit later. So they're doing some construction work here, and I don't know if that's causing problems with our internet or not. Sorry, my apologies. This might be a much shorter workshop than I was hoping. All right, I'll switch back to Chrome, which is apparently working. So here is a review wizard that I did earlier. Hopefully Mel will edit out the internet problems. So as you can see, this one's filled out a lot better, a lot more details, some searches in there. So the whole idea is that when you're done, you come down to the method section, and when you hit generate output, what this will do is, so this is an introduction I wrote, but what it will do is it will write everything from the method section down. So the eligibility criteria. So based upon your inputs, all of the different bits and pieces you put into the study, you answered, it will then pull out and write words around that for you. So I'll tell you what each author did, search strings, screening, who did the screening, data extraction, the type of data you're extracting, contributions, and then here you can see the PubMed and the Cochrane and the Embase search strings. I didn't put a date in, but if you don't like it, you can also hit rewrite, and it will rewrite it for you slightly. So there's no AI in here. These are random sentences drawn from reviews that we've done or sentences we've written. So everything is written by us. There was no computer sort of interaction. It just randomly picks pre-written sentences that we wrote. When you're ready, when you got one you like, you can copy it, paste that into a document, give it some edits, and then register it. So that's the whole idea. So we don't expect you to use the one from Fix Up Your Spelling as well. We don't expect you to use the one entirely without some editing from the review wizard. We can't get anything 100% perfect for people. So we always highly recommend just read through it, give it an edit. I mean, it's 90%, should be about 90% right, but there's always an extra 10% of work of editing and tweaking a bit of the wording. So that is the review wizard. So I'm going to blast through the rest of the tools now. The review wizard is probably the one that takes the most time. It's also the most useful one to get going. So I'll cross my fingers. All right. Thankfully, Google Chrome's working. I'm going to blast through the search tools. So we have a bunch of tools to help you do searching. In order to use the tools, you need references to process to help with your tools. The first tool is called the Word Freak tool. So when you design a search, it's very common to have a look at what's called seed studies. So these are pre-identified studies that you are aware of, that you've been identified normally by the content expert on your review. So in this case, I'm doing blue light still. So I upload these 10 blue light seed studies. This will import them, this will process them, this will read the titles, abstracts, and keywords fields, or the mesh term fields of those studies you uploaded, those seed studies. And it'll just tell you which words appear lots of times, with the idea then being you might want to use these words in your search. So for instance, you might want to use acne in your search. Oh, that's a cool hat. So you might put acne down as one of your search terms, and then you just go down the list and pick good ones that you like. So I'll grab blue light. So this is one of my intervention terms. Patience you wouldn't pick because, you know, everything's got patience in it, but LED you might pick as well. So again, that's an intervention word. So this is just to get you started, get you going. Phototherapy again. In fact, this is actually, I do design still a lot of searches for reviews, and I still do this every time I start a search. So up here, acne, and then I put lesions up there. This is just to help you get a search going. There's more stuff to do, of course. Once you've got some good words, you've got to put in field tagging and identify good subject terms. But it's just a good way to start structuring your search properly. So once you've got your words out and going, we have a tool called Meshmate. So Meshmate, if you're a search specialist and you already know what a mesh term is and can already find them very easily, Meshmate's not for you. You're better off just going off to the mesh database and just doing it however you do it at the moment. But if you're new to searching and don't really know what a mesh term is, it can be a good way to find mesh terms. So what you do is you just type in your word. This goes off and it goes off and searches the PubMed database or the mesh database really, and it identifies mesh terms appropriately for you. It identifies the appropriate mesh term. In this case, acne vulgaris is the mesh term for acne. You can add it in here and then you can copy it and then you can paste it in to your search. And it's just handy because it gives you the proper syntax you need to run it as a proper mesh term search or a subject term search. If you have no idea what mesh terms are, subject terms are, it's fine. Well, you know, you kind of got to, someone's got to know who's on your review. Hopefully you've got a search specialist who can help with that. But if not, pop into your local library. Well, not your local one, your university library. The librarians there, I'm sure, will be able to help you out and discuss and tell you what mesh terms are and help you with that part of it. So once you've got your search structured and you've got your mesh terms ready, you then move down to what's called the search refiner. So the search refiner is a tool to help you refine your search once you've got something going that you like. I might clear this. So there's two boxes. You've got to put your search in this box, and then you've got to put the PubMed IDs of your seed studies in this box. So here is my search. So this is a PubMed search. I put that in there. In here, I put the seed PubMed IDs, which are these ones. So these are 10 PubMed IDs of articles I know my search should find. When you're ready, hit the visualize button. This will go and run a search in PubMed for you, and it will tell you how your search is performing. And then you look at your search and you figure out if there's ways you can refine it or remove words to improve your search. So this does not help you find additional studies. It helps you refine and find fewer irrelevant studies. So the numbers to look at are in this top box here. There are, so this search currently finds 14,000 citations in PubMed, which is a lot. 10 relevant citations to find is how many seed studies did I upload for this search to find, which is 10. 10 relevant citations found is how many of these seed studies does this search find? Well, it finds all 10, so that's kind of good. So it's finding all the relevant evidence, but it's finding way too many irrelevant studies. So the idea is to have a look at your search and try to pull out words, remove words that maybe are low performing and which may help improve your search. So for example, pimples here, pimples finds 162 articles or citations in PubMed. That's the number outside of the bracket. It finds 0 relevant citations. So that's the number inside the bracket. So that 0 is how many of these 10 up here is it finding? It's finding none of them. Similarly, lesion down here finds 420,000 citations in PubMed. It finds 5 of my relevant citations. So maybe that's a word I could take out. So this is not a search session, so I'll blast through it. But basically, you find words that you don't like or you think can be safely removed. Just maybe all of them. And then from my intervention line, take out all of them, hit visualize again, and that will rerun your search without those words. And by removing a lot of terms that maybe we don't need, we've now dropped our number from 14,000 to 960. So I don't know what that is, a workload saving of, I don't know, 2 weeks. And it's still finding all my relevant citations. So that's the idea of the search refiner. Refine a search, remove irrelevant studies to reduce the screening burden later down for the other reviewers. That's search refiner. If you make a mistake, Control Z will undo whatever you did last. So then the polyglot search tool is the next one. So again, you just put in a search string, and then this will translate whatever search string you put in to a search string available, and that can be run in other databases. So I'm going to do it in Cochrane. So in Cochrane, it will only work if you go to the advanced search function and then the search manager. So I come to the polyglot. I paste in this case, my PubMed search. You can also paste in OVID searches as well. So you can paste in searches either from OVID, generally from OVID Medline, or from PubMed. And then all the databases it will translate into are all down here. So we've got the Cochrane Embase, different Embases, Cinals, Web of Sciences. We've even put in a business database recently to help with business reviews. And then we have a generic as well if you just want to run it in a whole bunch of different places without any field syntax. But I'm going to get the Cochrane library search. So you just hit the drop down arrow or grab it, copy it. You can also copy to clipboard with that. Paste it in, hit continue, and that's now my Cochrane search finished. Same thing for all of the other databases. The one thing it doesn't do is it does not translate mesh terms to other types of subject terms. So it does not change the words. So it doesn't actually change acne vulgaris to whatever the appropriate subject term is in the other databases. So it doesn't translate mesh terms to M-tree terms or send out subject headings or psych info terms, whatever they're called. Again, if you don't know what I'm talking about, head into the library and they can explain it to you. That's the one thing you still need to do yourself, or you can go watch the workshop on searching where I cover kind of this aspect of searching in a lot of detail. So that's searching done. Once you've done all your searching, you can import the references into EndNote and or into TERA directly. Then you need to deduplicate those references. So here we have a deduplicator. You just upload a bunch of search results into the deduplicator, and hopefully it will deduplicate for you. So we have two algorithms to help. There's a question mark here which tells you which one to use, focused, or our recommendations, I should say, and relaxed. So basically they're named after whether or not you want to spend some time focused looking through the search results and the deduplicated results, or you want to relax and just run it automatically without having to worry about it. So the relaxed algorithm doesn't remove, so it's very safe. It's a very safe algorithm. It won't remove any unique studies, but it misses a few duplicates. So a few duplicates will be left that can maybe be picked up during the screening process. So you can run that safely, fully auto. Focused, on the other hand, focused means it detects the vast majority of the duplicates. So most duplicates will get stripped out, but there's always a few mistakes it made. So you need to review the results a little bit. So I'll use the focused version. So I'll find one with duplicates in it. I think this one with 1500. I'll hit deduplicate. So it'll run it. So we have 4 different criteria. We have extremely likely duplicates. So these are ones where we're very sure they're duplicates. Highly likely, again, these are most likely duplicates. I think these are 99% likelihood plus. I think these are not 85%. Then we've got likely duplicates. So if a mistake was made, and there'll be a couple, it will be in the likely duplicates set. If you've never used tools before, though, I always recommend checking everything. So, if you've never used a deduplicator, have a look through even the extremely likelies just to, make sure and just so you're comfortable. I used to do that. I've used it a lot. I don't check these two anymore at all. But I do always check the likely duplicates. So you can see here we've got, this is the trial registry entry, or the registered trials entry, and these are the publications. So this is actually not a duplicate of these 3, although they look very similar. So just hit the not dupe button, and that will then tell the deduplicator it's not a duplicate. If I go down, then we've got a duplicate set. So here we have, these would probably be the conference abstracts. So when they're presented at the conference, and then we've got these 4, which are the publications. So these are not actually all duplicates of each other. So we have to split this group up. Do that by split group. That then lets me go, okay, this one here and this one here are duplicates of each other. That then separates those 2 groups out to ready to be deduplicated. And then just keep going down till you reach the bottom. Now, the good thing is we've done done it so that the likelihood of there being a mistake is much greater towards the top of the list. So if there are mistakes made, it's far more likely to be at the top. So in the first 10 or 20 you look through, unlikely to be down the bottom. So it means you can, focus a lot when you get started and then cruise a bit towards the end. Then when you're done, you can save it if you want, export your results. So save your results, all references deduplicated. Probably done this 10 times at least. Save it. This will now get saved in my projects list here. There's somewhere in there it will say deduplicated 10 there. So that's a deduplicator. The screening tool is called Screenatron. Hopefully I don't have to switch back to Edge again. So the Screenatron tool will help you screen. So it's a very strange thing going on today with the internet. It's pretty straightforward and it's pretty common. It's a pretty common type of screening platform. So I'll just upload some references. You basically click on something and then you screen it. So there's a few hotkeys that we have in. So we have include, exclude hotkeys, which does make it easier. So exclude is a space bar. Include is a right arrow, or the 1 button or the 2 button. If you don't like those buttons, you can change the buttons and the group name and even the colors. It's got a progress bar that helps as you screen, include, exclude keywords. So if you put in a include keyword, it'll highlight it green. If you put an exclude keyword, I'll just make one up. It'll be red. You can show abstract by hitting A button or clicking the hide show abstract button. Again, when you're done, you can even voice activated screening, which I won't go through because time's getting tight. And it's also got a search function as well, which can be handy. So you can search all the different fields as well. So maybe you just want to look at the ones where blue light is in the title. So you can just find those. It can be a handy way to screen the more likely ones right at the start when you're still fresh and interested. So that's screening really. So I'm not going to go through it too much since screening tools have been around for a very long time. We have a few quality of life things which are handy, primarily the hotkeys, I guess. When you're done as well, you can save progress as you're going. Hit the save button up here, which is always a good idea. All of the tools auto-save every 15 minutes as well, just in case you forget. When you're done, save results, and we recommend just saving your include groups. The next tool that will hopefully work is the Mecha Screener tool. So the Mecha Screener tool is for automatic screening. So we've tested it a lot. So we've found that it safely reduces workload by about 50%. We've done a couple of tweaks recently It was running with an accuracy of 98.7%, so therefore, so it correctly included 98.7% of the actual includes and removed 50% of the excludes accurately and safely. We've tweaked it now, so I think it's 100% on screening. So you put in your references, hit continue. Population, I think people with acne. So it uses a large language model, and the large language model prefers it if you're a bit descriptive. So patients, phototherapy, and outcome I'll ignore. Types of studies I'll just put in randomized trials and hit continue. So it uploads them through, it runs them through the large language model, which decides whether it's an include or an exclude, and it puts it into the appropriate groups for you to start screening. So it's excluded 336, included 221. So it's, although it's safe, it doesn't do everything for you. You've still got 221 left that you need to screen. You can screen in Make a Screener if you like. It's got most of the things that were in Screenatron, or you can save references, export references, I should say, and screen them in other tools. Due to the time frames, I'm moving on. Probably going to finish at about 11:05 a.m., but I'll blast through quite a bit quicker now. So when you screen in parallel. At some point, you're going to have to compare your results. To do that in Disputatron, which if I put in these ones, and I put in those ones, you can put in the number. So I might have screened 100. And maybe me and Mark did some screening, hit submit. This will compare those two libraries. Oh, they're the wrong libraries, but anyway, and it will give you your article agreement rates as well, and payback and Cohen's coefficient. So the idea is you go through, you have a look, and you decide between yourselves whether to include or exclude. When you're done, save your results, and if this is when you're doing total abstract screening, these are the ones that would take you through. These are the full text screening you would do. Next tool is SpiderSite. So SpiderSite's a tool to do the backwards and forward citation searching for you automatically. You upload some references. So generally these are the included studies found via your search. This will automatically find all of the reference lists, all of the articles in the reference lists, and all of the articles that cited those articles. It also tells you how many it found. So it found 9. There's still 1 to do yourself if you really want, although I probably tend to ignore it these days. If I go to the output section, here there is the backward citation search. So this is the 184 articles from the reference lists of all of those studies I uploaded. And this is the forward citation search. So these are all the articles that cited the articles I uploaded. You can save them, and then you generally screen these to see if there's any additional articles you might have missed with the search. The next tool is TERA. So TERA is a good way to find additional relevant studies. I normally use it at the start of a review, but you can also use it at the end. Again, you just upload some references. I'll get these 10 again. So it'll extract the PubMed IDs from them, and it will then go and try to find them in PubMed. And then if you hit find related, it will find out all of the articles that PubMed thinks are related to these articles, and it sorts them by PubMed's algorithm of relevance. So PubMed makes this determination of relevance, not us. There's 1,244 related papers, but don't screen them all. I only screen the first 50. So if there's something you missed or there's something else relevant that you might use, it'll most likely be in the top 50. So it's either a good way to just check to make sure you found everything at the end of your review, or I use it to try to find additional seed studies at the start of the review. So that's TERA Pharma. Calculon is the next tool that we have. So Calculon's a great tool for doing stats. If you have some stats for your review, it will provide the rest of them for you. I'm not much of a stats person, so I don't quite understand why it's so good, but apparently it's really good. So if in group 1 you had a mean of 4 and a mean of 5, and both groups had 20 people in it, and you have a p-value of 0.15, what it will do is it will then do the stats for you and provide the numbers that you're missing, such as the standard deviations, standard errors, kind of the confidence intervals, all on the same table, which is very handy, apparently, when you go to do the stats. So if you know what stats mean, apparently that's a really, really neat tool. This was built by us, but also in collaboration with Mark Jones, who's a super talented statistician, and he loves it. So if he loves it, it must be pretty good. There's 2 tools left. Meta pairwise. So we have 3. I'll only show one of them, but we have 3 meta-analysis tools. These are great tools built by our collaborators at the University of Leicester and University of Glasgow. So meta pairwise is doing simple pairwise meta-analysis, your standard normal meta-analysis you see everywhere, or the most common type. Meta Insight is for doing diagnostic test accuracy meta-analysis. Oh, sorry, no, network meta-analysis, sorry. So Meta Insight is for network meta-analysis. Meta DTA is for diagnostic test accuracy meta-analysis. I'm just going to use Meta Pairwise to do a pairwise meta-analysis. So you upload some data. So the data's got to be in an Excel spreadsheet. They have some great format requirements. They tell you exactly how it needs to be formatted. They give you some good examples of what it needs to look like. So you can just download these spreadsheets and modify them and change them and fill them out, copy their format, upload it back in. The format it needs to be in is this one, which I'll upload in a second. So the study, treatment arms, so phototherapy and then placebo, number of events, number of people. So that's what it's got to look like. So you can just download their template from their website. Which is what I'll do. So I'll upload some data. Then go to the calculator. Then you can do some Bayesian stuff too if you're a Bayesian person. I'm just going to stick to frequentist stuff. So then you run your frequentist meta-analysis and it processes it and it runs it. So this is the meta-analysis now done. It does both fixed effects and random effects for you, and it plots both of them on the same graph. You can download the forest plot also does a Larvae plot if you're interested in those. You can download the whole thing as a PDF or just a image as well. The last thing though is it can be downloaded. So these numbers and these results can be downloaded as what's called a JSON file, which doesn't really matter, but basically it's just all of the data and information in that forest plot gets downloaded as this JSON file. And you can take that JSON file. If I now go to the replicant tool, I think I've got one uploaded. Yep. So if you put that JSON file here into the replicant tool, it will then write the results of that meta-analysis for you. So it pulls the numbers out. So it goes through and it knows that there's 9 studies were in the forest plot or were meta-analyzed. Those 9 studies had a total of 3,245 participants, 1,600 in reference group, 1,642 in the intervention group. And it just writes this results section for you based upon that forest plot, which is really useful because it removes those transcription errors of trying to copy, from Excel spreadsheets into Word documents and everything else. So those transcription errors that commonly occur. It also gives you information about each of the individual study results as well. And it also helps you a little bit with the results of the search. We don't put these numbers in for you yet. You still need to put those numbers in yourself. And then finally, if the internet holds up, if I go back to the review wizard and I go down to the results section, it actually fills out and it puts the results from the replicant tool into the review wizard as well. So when you do generate your output, it now has some results filled out, which again, you need to do some editing, but at least you've got it starting to get a structured results section ready for your manuscript as well. And that's it. We have lots of help files for everything, and then help videos on the front page. Any bugs or any problems, please contact us. There's about 5 of us who get these emails, so someone will be in touch pretty quick. Profile. So if you're using the free account, you'll have 1,000 credits. If you're using the subscription account, you'll have 10,000. That's pretty much it. This is all we track about you is your email address and your name and your initials and your institute if you put it in, but you don't even need to put that in. So we don't really track, we don't want to track anything, and we don't really track anything. And then finally, the CITES page. If you do use the tools and you want to cite the tools, we've got a few papers here for some of the individual tools, but if you just want to cite TERA, you can just use that paper there. Finally, in case anyone's thinking or is going to ask, we are going to run a proper trial of Mecha Screener soon. This year, hopefully publish either late this year, early next year, to see how it performs when used by real people to do a review. And that's it for all the tools in TERA. So my apologies for the internet. Since the construction slowed down, it seemed to fix itself up again. That was a bit odd. If you want to hang around, I'm now going to answer. Oh, and my apologies for going 6 minutes over. But those of you who want to hang around and ask questions, please feel free. Come off mute if you like. I'm going to go through the 11, well, they might be questions, and hopefully answer them succinctly if I can. So Michaela has asked, I can see Systematic Review Accelerator still online. Is it still supported? Will it be discontinued? If so, what's the time frame for this? We're leaving it online for the time being till the end of the year, at least, end of 2025. But slowly over time, we're going to discontinue some of the tools, which generally are better anyway. So the methods wizard we have in the SRA, the old platform, is kind of old, and the review wizard, which is the new one in TERA, is actually much better. So I will discontinue that first. Over time, we'll discontinue most of the tools in the SRA, and expect people to move to the new platform. But it doesn't really cost us much time, effort, or money to keep it up. So we'll kind of keep it up while people are still using it. So at least 6 more months. Maybe we'll keep some of it still up and running through 2026 as well. We don't want to shut it down till people have pretty much migrated over to TERA. So we're going to keep supporting it, hopefully, I guess, until people stop using it. I mean, probably a bit before that, but yeah, the plan is at least until the end of 2025, probably halfway through 2026. Cheryl's asked, what's your practice in the credit system for assigning recognition for search support, i.e. which credit category do you cite? Yeah, I tend conceptualization methodology is pretty good. I don't really like to be honest, I don't actually like the credit system very much. I think there was a one previously that I liked more. Um, but yeah, we use credit since that's the one all the journals seem to use. I just pick a couple. There's only methodology, conceptualization methodology, and then writing some stuff, helping with the writing or writing the drafts. I think there's only 3 or 4 I ever pick. Um, so Mina's asked, is search, oh, and then Mina's also asked conceptualization methodology. Yeah, basically pretty much the same. I think there might be one more, but not a lot of them are actually that relevant to reviews I've found either. So Mina's also asked, is search refiner designed with sensitivity in mind? Yes. Wait, which one's sensitivity? Uh, it's only designed with refining, which is precision in search terminology. I don't know if that's sensitivity or specificity, but it's only really designed to remove words and refine the search to remove irrelevant studies found. It doesn't not really designed to help you find additional relevant articles, although you can use it for that. It's really designed to refine your search and, you know, decrease the number of articles found by your search, safely decrease. Roshan's asked a few questions about seed studies. What are these papers? Yes. To answer your question number one, are these papers that we have identified in our own searches that would definitely be included in the review? The answer is yes. They can also be papers that you would probably include in your review as well. And they don't have to be 100% includable, but generally the idea is a seed study should be a study that would be included after title abstract screening. It might be excluded during full text screening, but it should be something includable by title abstract screening. I tend to try to stick to the ones included in the final review, but if you want to find a few more, you know, pretty much close to 100% relevant, but yeah, it's a bit of a magic black dark art, to be honest. Is there a recommended number of seed studies to have? As many as you can is the recommended one. So the way I look at it is the fewer seed studies I have, the less trusting I am of the performance of the tools and using the tools. If I've only got 3 seed studies, I'm very cautious when using the search refiner tool, for instance, because it's not a big sample. So, there's a lot more of my own judgment goes into the search. If I've got 20 seed studies, I don't worry about my own judgment too much. For the most part, I, trust the tool and trust 20 is going to be a good sample. So it depends on the number. Around 10 is really good. 10 or more is a pretty safe set. Anything under 10, there's a lot more of your own judgment has to go into using the tools. Paulina's already answered. Thank you, Paulina. Basically what Paulina said. So Rebecca's asked, how does it work when 2 people screen when they are collaborating on a project? Who has access to what output? You have access to your own output. So when you start screening in Screenatron, it splits the project and creates 2 different separate instances. So I guess, Rebecca, if you and I were screening on a review, my Screenatron, once I started screening, would split and it would create a Justin Screenatron instance. And when you started screening, it would split and create a Rebecca Screenatron instance. We both then would save, like when we're finished, we'd both save our include list to the same project list. Yours would be called included RT, I think. Mine would be called included JC. So it splits it and there's 2 separate instances. So you're both screening separately from each other. Hopefully that that made some sense. So you split your screening, saved back it to the same, set of files lists. Oh, thank you, Megan. Thank you, Mina. David's asking, TERA be used for non-HSM research topics, e.g. built environments and economics? Excellent question. Yes is the yes with a big asterisk is the short answer. We actually did try to get some money from the ARC to make it better for people outside of health because we work in health and most of our funding has come from health grants and health funding. So that's kind of been our focus. Most of the tools though are usable outside of health. A couple of the search tools, not so much. So Search Meshmate and Search Refiner API into PubMed. So they're not really, well, not at all useful outside of health. Most of the rest of the tools, oh, and Terraform are also APIs to PubMed. So again, that's not usable. Every other tool, I think, is usable outside. Oh, Polyglot 2 doesn't translate into the databases. So most of the search stuff is focused around health. All of the other tools are usable. I mean, screening is screening, right? It doesn't matter. The eligibility criteria can be business or economics. It doesn't matter. You're the one screening. Mecha Screener, we haven't tested it, but we're too much, but we're pretty sure it works very well outside of health as well. If you get your, criteria correct. So 80% of the tools are available and usable outside of health. It's a good question. We would like to make it more accessible to people outside of health. And we will be trying to put in a grant with the ARC again this year to try to get some funding to help us do that. Thanks, Roshan. Thanks, Alistair. Rebecca, thank you. Gabriella, Will. And Piana, thank you. And I'm glad that we managed to get your registration sorted. It's glad that we could make it.